Hi guys, welcome to Science in 5. In this video we're going to discuss trigonometry on the Cartesian plane. Previously, in our last video we said, well, using SOHCAHTOA, the sine of an angle, the cos of an angle, there's a simple way of remembering that. We said the sine of theta was the opposite over the hypotenuse, the cos of theta was the adjacent over the hypotenuse, the tan of theta was the opposite over the adjacent. Okay. Now on a Cartesian plane, we can still determine the ratio of these angles, but it changes a little bit. So suppose if I draw a line like that, I make that angle theta, then I make a right angle triangle. This length here is x, that length there is y, that length of that right angle triangle will be r. So using theta as the reference angle, the sine of theta becomes the y over the r. The cos of theta becomes the x over the r. The tan of theta becomes the y over the x. Okay. Notice that in this notation, when we're working out the ratio of sine, cos, and tan, the r is always positive. Always. R must always be positive. The x and the y can change. They can be positive or negative. Consider the x. The x is positive when you move in that direction. You move in that direction, the x becomes negative. The y, you move in that direction, it's positive. You move downward, it becomes negative. Okay, so that's the first thing. All right. Now, the other thing that we can see as well is that the tan ratio is a combination of the sine and the cos. Okay? We can actually prove that the tan of theta is actually the sine of theta over the cos of theta. How do we prove that? Well, the sine of theta is y over r. If we divide it by the cos, it's going to be divided by x over r. But in maths, you know that division of fractions, you can change division sign to multiplication and then you invert. So once you invert that, you're going to cancel out the r's. You're going to remain with your y over x. So the tan is actually y over x. Y over x is the same as the tan ratio. So the first thing that you must remember, guys, is that this is an important relationship. The tan of theta is equal to the cos, the sine of theta over the cos of theta. Very important to remember that. Okay. The second relationship that you need to remember, well, it's related again to the right angle triangle that we see there. Okay. The right angle triangle that we see there. Well, the right angle triangle that we see there, we can use the theorem of Pythagoras. R squared is equal to x squared plus y squared. Okay. If we divide by r squared throughout, we're going to get 1 is equal to, now x squared over r squared. X over r, we've just said, is the cos ratio. So the cos ratio is now being squared. So when you say cos theta times cos theta, we write it as cos squared theta. This becomes the sine squared theta. That is another, again, the second relationship that we must quickly remember, guys, is that 1 equals cos squared theta plus sine squared theta. So when you're working with the angles on the Cartesian plane, we are now coming up with these expressions. We call these identities. Okay, this is the tan identity. That's the Pythagorean identity. Very important to note that these are the most basic relationships that you have to know and know how to work around with this. Okay, so on the Cartesian plane, the sine of theta we know how to work around with, the cos of theta, the tan of theta. We've identified two important relationships. Okay, in the next video we're going to build on this and we're going to add more information, guys. Thanks for watching. I hope you understand how the angles work on the Cartesian plane. In the next video, again, we'll talk about when does the cos become negative, when does the sine become negative, when does the tan become negative. I'll catch you guys in the next video. Stick around, don't disappear. Stay with Science in 5.